The first video in this series explored how the metre came to be the standard unit of length during the French Revolution, and how the current list of 24 metric prefixes came to be. In this video, we will focus on how to correctly write and use the prefixes, and how to change from one to another. Let's start by getting the notation right. There should be a space between the numerical value and the metric prefix, but no space between the prefix and the base unit being used. And the units of measurement are not written as italics. This is reserved for algebraic variables. Of course, it can be difficult to tell the difference when using handwriting. To better understand how the prefixes work, let's consider groups of our standard metre, starting with 1 metre. A group of 10 metres can be called a decametre. Whenever we use the prefix deca in front of any unit, it means 10 of them, and the symbol is a lowercase da. If we now group 10 decametres together, we get a group of 100 metres. And the prefix for 100 is hecto. Its symbol is lowercase h. Hecto in front of any unit means 100 of them. Finally, grouping 10 hectometres together gives us a group of 1,000 metres, known as 1 kilometre, often pronounced kilometre. The symbol is a lowercase k, the last of the lowercase prefixes that represent whole number multiples. We could technically continue to megametres, gigametres, etc. Knowing what the prefixes mean makes changing from one to another much easier. Kilo should always mean 1,000 of the base unit, at least when it's used correctly. There is some confusion due to the misuse of the prefixes when talking about computer memory and storage. This is because computer memory operates in base 2, and 2 to the power of 10 is 1024, very close to 1000. Since binary powers are indeed useful, there are also correct names for these prefixes, but that's a topic for another video. So whenever you hear kilo, it should mean 1,000. A kilogram means 1,000 grams. The metric unit for measuring air pressure is the pascal. A kilopascal means 1,000 pascals. And the symbol for a litre is a capital L. A kilolitre is, of course, 1,000 litres. It should also be obvious that 2 kilolitres is 2 lots of 1,000 litres. 3.4 kilolitres is 3.4 lots of 1,000 litres, which is 3,400 litres. We can apply these techniques to any prefix with any base unit of measurement, providing you really understand the prefixes and their meanings. Notice that after kilo, the larger prefixes are denoted by capitals. Once this naming convention was established, lowercase symbols were restricted to the fractional multiples. Perhaps one day the Bureau of Weights and Measures will see fit to change these 3 to capitals as well, to match the rest of the large prefixes. We will restrict our list to cover prefixes from tera through to pico only. This gives us values that aren't ridiculously large when written in decimal form rather than powers of 10. For those not yet familiar with index notation, it's easy enough to see the connection between the powers of 10 and their decimal and fraction equivalents. For positive powers of 10, the power matches the number of zeros after the 1. For negative powers of 10, it's simply the reciprocal of the matching positive power. In other words, it's 1 over the same value as the matching positive power. In decimal form, the power tells us the total number of decimal places, and if we include a leading zero, it conveniently matches the total number of zeros as well. It's sometimes useful to be familiar with recognised naming conventions as well, which follow the American definitions for billions, trillions, etc. The fractional values, thankfully, match these descriptions. The advantage of using powers of 10 is how concisely the values can be written. At the end of the video, I will cover some bonus techniques for converting between the prefixes using these powers. But for now, let's stay with the factors written as whole numbers and fractions. The ingenuity of the prefixes lies in the fact that they are all base 10, just like our number system. This makes calculations much easier than those with any imperial or customary units of measurement. It's often a simple matter of moving the decimal point to the left or the right, depending on whether you're multiplying or dividing. More on this in our worked examples. To help you develop a better understanding of how they're all related, we can create a flow diagram showing how one prefix can be exchanged for another. Changing from one prefix to a smaller valued prefix means you will have more of them. It's like cutting it up into smaller pieces, so we multiply by the number of smaller pieces that fit into the larger one. Changing from the smaller valued prefix into a larger prefix is the opposite. It's like gluing the pieces back together. So we have to divide to see how many of the larger pieces we can make. Changing from kilometres to metres, we need to multiply by 1000 and drop the k. This applies to any base unit, which is the reason for the success of metric prefix notation. I'm going to use litres as my base unit, but you can replace it with any unit at all, even make up your own. After kilo, all the larger prefixes are simply 1000 times bigger than the previous. We can continue our flow diagram for each of these larger prefixes. Mega is 1000 lots of kilo. So, to change from megalitres to kilolitres, we multiply by 1000. But mega literally means 1 million of something. 1000 times 1000 is 1 million. So, we could multiply and divide directly by 1 million if we want to. But it starts to get too messy, so we will leave it out. The next prefix is giga, which means 1000 times larger than mega. It means 1 billion of the base unit. Then tera, which means 1000 of the giga prefix and literally 1 trillion of the base unit. We won't go past tera in this flow diagram, but it's easy enough to add any larger prefix as the need arises. Peta comes next and is simply 1000 times larger than the tera prefix, and so on. I've stretched out the section between kilo and the base unit so we can now include the prefixes deca and hecto. Remember that deca means 10. We multiply or divide by 10. Hecto means 100, which is 10 lots of 10, so the conversion factors between hecto and deca are also 10. And 10 lots of 100 is 1000, so conveniently the conversion factors from hecto to kilo are also 10. Since hecto literally means 100, we could multiply by 100 to go straight from hecto to the base unit. But once again, it looks a little too busy and we will leave it off this flow diagram. You could always use the relevant definitions or combinations of factors if you understand them well enough. Now let's continue our flow diagram into the fractional prefixes, multiplying by the relevant factors as we move to the right, because we are cutting them into even smaller pieces. Milli means 1000th. Let's include deci and centi using the same reasoning we used for deca and hecto. Deci means 1/10. So the conversion factors are again 10. Centi means 100th, which is 1/10 of 1/10, so the factors again are 10. And 1/10 of 100th gives us 1000th, which is the prefix milli. All remaining conversions will be factors of 1000. Micro is 1000th of milli. Then nano is 1000th of micro. And finally we have pico, which is 1000th of nano. And here we have our complete flow diagram, beautifully symmetrical. Since it applies to any base unit, not just litres, we can remove the litres. Hopefully, the consistent use of 1000 for the major factors and 10 for the others will make it easy for you to remember. Of course, you have to remember the correct order for the prefixes. A good old-fashioned mnemonic or similar memory aid could help. I'm sure you could come up with something better. Now for some examples converting between prefixes. We are not changing the actual value of the measurement. 2 kilometres and 2,000 metres, for example, are exactly the same distance. In part A of example 1, we are asked to change from gigalitres to megalitres. Looking at the flow diagram, we can see that to go from gigalitres to megalitres, we multiply by 1,000. Because everything is base 10, we don't even need a calculator. 1,000 has 3 zeros, since it's the same as 10 to the power of 3 or 10 times 10 times 10. We simply move the decimal point 3 places to the right and fill the empty spaces we jump with zeros. Of course, use a calculator if you prefer to do so. In part B, we want to change the same 3.7 gigalitres into kilolitres this time. Since we already converted to megalitres in part A, we can start there if we like. We only need to multiply by 1,000 again. This gives us 3,700,000 kilolitres. If part A hadn't been asked, we would start with 3.7 gigalitres and we would need to multiply by 1,000 twice. Or we could multiply by 1 million, since 1,000 times 1,000 is a million. A million has 6 zeros, so move the decimal point 6 places to the right. In part C, we want to change into litres. Again, we could start with part B having already converted to kilolitres, so we just need to multiply by 1,000 again. This gives us 3,700,000,000 litres. If parts A and B had not been done first, we would start with 3.7 gigalitres and multiply by 1,000 3 times. This is still the same as moving the decimal point 9 places to the right. Another way of saying 3,700,000,000 is 3.7 billion. If you know the prefixes and their meanings, you could have started by knowing that giga means billion, so 3.7 gigalitres is 3.7 billion litres. 1 billion is a 1 followed by 9 zeros, so we also know to move the decimal point 9 places to the right if we want the decimal form. Our conversion in example 2 is going in the opposite direction. We want to change 582,000 litres into kilolitres. Let's do this the short way first, knowing that kilo means 1,000. If you listen carefully, we have 582,000 litres. The answer is right there, 582 kilolitres. Failing that, we could look at the flow diagram and see that to change from litres to kilolitres, we need to divide by 1,000. 1,000 has 3 zeros, but we are dividing, so we move 3 decimal places to the left. Example 3 is slightly more challenging. Looking at the flow diagram, we want to go from centilitres to kilolitres. Dividing by 10 gets us to decilitres, then dividing by 10 again gets us to litres. Finally, dividing by 1,000 gets us to where we want to be, kilolitres. Without a calculator, I simply add the total number of zeros in the factors that I'm dividing by. There are 5 of them, so I need to move the decimal point 5 places left, remembering to write in zeros in any empty spaces. Alternatively, combining the factors for centi and deci, or knowing that centi means 1/100th, we could have divided by 100 first to get to litres, and then 1,000 to get to kilolitres. It's still 5 places to move the decimal point. We will finish off the video with a more advanced concept, showing how our examples could have been done quite simply by subtracting their powers of 10. When listing the powers, don't forget to include hecto, deca, deci, and centi. The real benefit comes in knowing the prefixes and their powers, so there's no need to even draw the flow diagram. If you remember the order through a mnemonic or acronym, again, don't forget to add in hecto, deca, deci, and centi. Now we're set to go. Step 1 is to find the difference between the two relevant powers. If you subtract in the direction that you want to convert, the resulting sign tells you which direction to move the decimal point. Let's look at another example. To change from kilo to deci, the difference in the powers is positive 4. So we would move the decimal point 4 places to the right. Going from micro to giga, the difference in the powers is negative 15. So we would move the decimal point 15 places left. In example 1b, we were asked to change 3.7 gigalitres into kilolitres. Looking at the powers, we want to go from here to here. Subtracting the powers gives us positive 6, telling us to move the decimal point 6 places to the right as we did before. The advantage here is that we can go straight to our answer. As a final point, advanced students will sometimes leave their answers in scientific or standard notation. I hope you have found this video useful. Please like and subscribe. It helps me make more content for you.